like the first question, the third question, the third question is there, and questions related to the multiplexers also, like the
Just
last
wait a minute.
number.
Just wait a minute. Just wait a minute. I can't hear you properly. So use headphone. Yes. Now tell me. Hello.
Uh,
Can you?
yes, sir.
Yeah.
Practice as graded assignment question number 3.
Graded assignment question number three. Okay. Any other? Single question?
Question number 3, question number 5, then question number 10, then 13, 14, 15.
Yes, sir. Same doubts. Question number 5, 10, and 13.
Okay. I'm just share screen. Question number three. Question number 3, 5, 10, 13, 14, and 15. Is it?
Hello, sir.
Yeah.
I have doubt in the other question.
Okay. Tell me the question number so we will solve here.
4 and 6 to 9.
4 and 6, 7, 8, and 9. That means completely, I think we start from the 3 to 15. Okay. So I just take the question one by one. So, okay, this is the question number 3. Okay, so here if I see, we have a P. Okay, this is also P. Now you can see this is the XOR gate. So when one particular terminal is connected to one, this particularly XOR will behave as a inverter. We already discussed that one. So here we are getting a Q bar and Q bar. Clear? So Y is R bar, S bar. That means both are 0, 0. Which particular line will be selected? I naught will be selected. So that is Q bar. Plus when we apply the 0, 1, so R bar S, I1 is selected and I1 is P, plus when 1, 0,
Yes, bar.
so R S bar, then Q bar is selected, and when R S P is selected. Okay, now if I am going to create a K map, okay, now first of all we check question one more. I0 to IG, the input of the 4 plus 1 marks, RS are the control bits. The output Y can be expressed. Okay, so how can we express the Y? So I just take a P and Q, R, and S. Okay, it is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Now, if I see the R bar, S bar, so that means this particular line. Okay, and Q is also 0. So Q is 0 in two positions. So 1 and 1. Both term will be defined. Either I convert into the canonical form, okay, or I can directly write it here. Now, R bar S, that means R is 0, S is 1. So that means this column. Under this column, P is 1. So where P is 1, P is 1 in this two. So this two. Okay. RS bar, that means this column. Again Q is 0, so 1 and Q is 0, so this and this column. And RS, this column, P is 1, P is 1 in these two scenarios. So 1 and 1. Okay, now we have a 1 and 1 this. One group is this one, and one group is this one. Okay, so Y is, if I write about this group, so the term is PS, because P is 1 and S is 1. Okay, and if we are talking about the corner, so Q is 0 and S is 0. So Q bar S. Okay, so one answer is this one. Second, if you see that in the question number 3, 2 answer in SOP form and 2 in POS form. So we check the POS also. So we try 0, 0, 0, 0, 0, 0, 0, 0. So one is this one. Okay. One group is this one. So if I am talking about this group, so for this one, the term is P is 0. So P and S is 1. So P plus S bar. And for this group, Q is 1. So Q bar and S is 0. Q bar plus S. Okay, again we check the options. So in option you can see 2 terms are not available, 3 terms are available. That means they are creating one more group. Okay, and in the question you can see that there is no simplified. They are not asking about the simplified expression. So one more group is created here. Okay, so for this one the equation is P is 0, so P plus Q is 1. Okay, so P plus Q bar, P plus S bar, and Q bar plus S. Okay, so second and fourth option.
Hello, sir.
Yeah.
So in the first two, P plus S bar and Q bar plus S,
Mm-hmm.
we cover the all zero. So
Yeah.
why we use P plus Q bar?
Like thing is that I just tell you that if we are talking about the simplified Boolean expression, okay, then this is the correct answer. Only if I am talking about the simplified. But when simplified term is not used, this answer is correct as well as this answer is also correct. Okay.
Okay.
Now
Okay,
you
sir.
can check. You can check according to the option. The option, this option is not available, but this option is available.
Yes, sir.
So I choose this option. But if simplified expression they are asking, so only this option is correct, only this option is correct. Because we use the simplified term. Understood? In the last class, I think we all discussed about this one. What is the basically use of simplified? Why we write, if we write a simplified, so what is the meaning of that one? Yes?
Yes, sir.
So that's why. Okay, options, this option is available, so that option is also correct. But in the simplified form, this option is not correct.
Sir,
Yeah.
sir, in the last class, you said that like you have did this multiplexer question in different way. You had said not to follow the K map, and for the upper row you are taking like 0, 0,
Uh,
0, 1, 1, 0, and
Yes,
1,
sir.
1.
yeah, thing is that when I select, if you write the equation, so what is my equation? Y is S1 bar, S0 bar, I naught. Remember that?
Yes, sir.
Yes, sir. Okay. Now the representation is opposite. in place of I naught here, I just write I naught here. But that doesn't mean that it is I3. Okay, that doesn't mean it is I3. This is always a I naught. Understood?
Yes, sir.
If I write a S naught here, S1 here, so S1 is always a MSB. Okay, generally this select line, in the case of select line, we write in the left side, we write a S1, and in the left side, sorry, in the right side, we write a LSB, and in the left side, we write a MSB. Okay, the sequence for this one is always this side is the LSB and this side is the MSB. But if suppose by mistakenly I write a S0 here and S1 here, that doesn't mean that if I select a 0, 1, it will be I2. Okay, it is not a I1. Not a I1. It is always a I2. Why? Because S1 is 1. Clear? S1 is 1, S2 is 0, that means I2. Not a I1. Understood, or I should repeat it again?
Yes, sir. Got it.
Okay, what is my representation? That is different, because that is the, if we are talking about the pin IC. Okay, if we are talking about the IC, we know that the first pin is I naught. But sometimes the IC will be started here. Sometimes you can write a IC like that way. Then this is the I naught. Okay, now here it is I3. So first is the I3, then I. Here it is I naught, then I3. Okay, so that is the way, different way to hold the IC. But that doesn't mean that first pin will behave as IC. That is always a I naught. Okay, so similar case here. I naught is always I naught. Either you represent in the lower or either you represent in the upper. Okay,
Yes, sir.
clear? Now any doubt in question number 3? Okay, question number 4. What is the minimum number of 2 cross 1 marks required to generate a 2 input OR gate and 2 input XOR gate step? Assume complementary inputs are not. Okay, so we required a 2 input OR gate. Two cross 1 marks. So we have a, we required a plus B. Okay, can I write it down as a plus A bar B? Because according to the distribution law, A plus A bar B is what? A plus B. Okay, any doubt?
No, sir.
Can I write it down as a bar B plus A times 1? Okay, now 2 cross 1, that is one select line. If I connect A as a select line, so when A is 0, that means A bar. And when A bar, what is the input? Input is B. So I connect B here. When select line is 1, I1 is selected. And what is I1? 1. So Y is simply A plus B. So how many XOR gate is, how many gate is, sorry, mux is required? 1. Now second is, we have to solve Y is equal to A XOR B. So A B bar plus A bar. Now it is up to you which you use as a select line. If I use as a select line as a bar, sorry, A as a select line. Okay, so when A is 0, that means I naught is selected. So I naught is connected with B. Okay, and when A is 1, B bar as a input. y. That means you required a 1 2 cross 1 marks. Okay, any doubt till now?
No, sir.
Okay, now in the question it is saying that we don't have any complementary inputs. That means B bar is not available. Okay, so we have to create a B bar. We have to create a B bar. So we required one more marks. Select B as the input line. Okay, when B is 0, I naught is selected. Okay, so B is 0, so that means B bar. Okay, and when B is 1, 0, because we only required a B bar. So if I connect it as a 1, as a 0, what is the output we are getting here? Write the equation B bar dot A plus B dot 0. Okay, this term is 0, only B bar is remaining. Now we use this B bar for the input of I1. And here we are getting a XOR. Okay, so if complementary input is available, we required 1. If complementary input is not available, we require 2 more. Okay, any doubt?
No, sir.
Question number 5 is completed. Now question number 5. What is X?
So what is it?
What is X?
D3 plus D5 plus D6 plus D7.
D3 plus D5 plus D6 plus that. Okay, so we can create a K map. Okay, now you can see the I2 is connected with C. Let me see the MSB and A is the LSB. So we connect C here, B and then okay, so let me see D6 is connected, D7 is connected, D5 and D. So D3, D5, D7 and D6. Okay. So now you can write the equation for that. 3 terms are available. Okay, one group is this one group is this one, and one. Okay, 3 groups are available. Similarly, if I want to Y C B A, C B A. Now for the Y, D3, D5, D1, and D7. So D1, D3, D5, D7. Only one term is available. Okay. Any doubt? Question number 5.
Sir, can you simplify for the X part?
Okay. So for the X part, if we simplify, So first of all, this column matrix, it is AB or BA. For this one, C is 1 and A is 1. So AC plus for the this one, C is 1 and B is 1. So AB, BC and AC. AB, BC and CA or AC.
Sir,
Yeah.
sir, if I write directly rather than using this K map, like if I write for D3, C bar B A, for D5, C B bar A, for D6.
Wait a minute. You write as a C bar BA plus D5, that is a C B bar A plus for 6 you write a C B A bar plus C B A.
Yes, sir.
That is now from the first and last. Can I take a AB common? C plus C bar, that is 1 plus A bar B C plus A B bar C. Okay.
Yes, sir.
Now from this one and this one I can take B as a common.
One and third or one or two big one.
So A plus A bar C plus A B bar C. Okay, so this one is A plus C. B plus A B bar C. So this one is the AB plus BC plus A B bar C. Now from these two I can take C as a common. So B plus AB bar. So AB as it is plus C times A plus C. So AB, BC, AC. Okay. If you take other method, in every method this is same. Because in the KMAP you can see it is not possible to create another group. Okay, that means either you solve through the KMAP, either you solve through the Boolean simplification. In every scenario you get the unique answer.
Yes, sir. Got it, sir.
Okay.
Yes, sir. Got it, sir.
It's like, for example, we are getting in place of this one, we are getting 1 here.
Sir,
Now
your
maybe your
voice
answer is
is not
different.
clear.
My voice is not clear.
Now it's clear.
Now it's clear.
Okay. Yeah, now it's fine.
Yes, sir.
Okay. Now, like for example, we have this group. Now possible that you have a different terms. Every solution will be different. Why? Because one group is created here. One person create this group and another person create this and this group. Okay. The second group that you created, that is basically redundant term. No use of this one. Because one, this group is sufficient. I just change the color. One, this group is sufficient. And second, this group is sufficient. Along with that, if you create this second group, this one I am taking second group. If you take this second group, I just note down with the red. So that is redundant term. So in that scenario, may be possible that the answer will be different. But if it is not possible to create a separate group in the K-map, the answer either you solve through the Boolean expression, every time you are getting the same answer. Got it?
Yes, sir.
Question number 6. A memory is made of 512 rows and row decoder need to activate one of the row depending on the row address. This decoder will have an input AND gate. Enable input is a common input for all the AND gate. The value of M and N respectively. Okay, so you have to identify how many AND gate is required and how much is the input for a single gate, single AND gate. Okay, so you have a 512 decoders, okay, row decoders. So that means you created one decoder where 500 is the output pins, 512 output pins. Okay. Now for the 512 output pins, how many gates are required? How many output are? Sorry. Yeah. We have to design this decoder. Okay. With an input AND gate. So we are designing the an input AND gate. So we have 1, 2, 3. Okay, and so on. 1, 2, 3. Now we know that for the generation of 512 output, we required a 9 input because decoder configuration is n cross 2 raised to power n. So if I have to implement a 500 output pin, that means we required a 9 input pin. So that means there are the nine input for every AND gate. Clear? And how many AND gates are there? To generate a 512 combination, we required a 512 AND gate. That means one thing is clear is the number of AND gate is 512 and with every AND gate we required a 9 input. Understood? Any doubt in this one? Yes? Any doubt?
Sir, the AND gate is 512. Why?
Hmm. The 512 AND gate.
Sir, I say why?
Why? Okay. So you have created a basically 512 outputs because your decoder is 9 cross 512. Okay. AND gate
Yes,
generate a single output. That means how many AND gate is required to generate a
512.
512 output?
512.
512. Clear?
Yes, sir.
Now you required a 9 inputs because for a generator 512 output in the decoder, you required 9 inputs. So that means 9 input 512 AND gate required. Clear? Any doubt or should I repeat it again?
No, sir.
Okay. Now here one more thing is that enable pin signal is common input for all gate. So we already have a 9 inputs. Okay, because the 9 input is required and I just common all the 9 inputs 1, 2. Okay, these 9 inputs are common. But to control which particularly AND gate will operate at a single time, we required one enable pin also for every input, every AND gate. So 9 input is already available, plus 1 enable pin is required. So total how many inputs is for a single AND gate? 10 input. So we required a 10 input AND gate. Okay, we required a 10 input AND gate. And how many AND gate this input this required is 512 gates are required. Okay.
Yes, sir.
Now question number 7, the Boolean expression XYZ sigma, the minimum block required to implementation this one. Okay, 1 2 4 7 and 5 6 3 5 6 7. Okay, so if we use a 3 cross 8 decoder, so 1 I1 4 sorry 1 2 4 7, we required a 4 inputs and all connected with the OR gate. Okay, so we can implement S. The input is I2, I1, I0, that is X, Y, and Z. S, X, Y, Z. Okay, and similarly, we connect 3, 5, 6, 7. 3, 5, 6, 7. And we use one more AND gate to combine all this. So we are getting a X, Y, Z, that is, I think, C. Yeah. So that means 1 3 cross 8 recorder and 2 4 input OR gate. Okay. Similar to this question. Question number 5. Okay, but only we have to change the pins. Any doubt?
So it explain again the last part.
Okay. So we required S, X, Y, Z is sigma M 1, 2, 4, and 7. And C, X, Y, Z is sigma M 3, 5, 6, and 7. Okay, so what should I do? I just use a 3 cross 8 decoder. Okay, that will be generating 8 inputs, 8 outputs on the basis of 3 inputs. Now
Yes.
we required a summation. That means this is the SOP term. SOP term is every term is in product term and that will be added. Okay, so that means we required a one OR gate.
Yeah. Okay, sir.
Okay, and how many inputs we have to connect? 4 inputs. So that means we required a 4 input OR gate. Okay, one 4 input OR gate for S and one 4 input for gate for C. Okay, and one 3 cross 8 decoder. Clear? Any doubt?
No, sir.
Okay. The total number of NAND gate required to implement a 4 cross 1 mux, assuming NAND gate of any of the inputs are available, complement input are not available. Hmm.
Sir,
So yeah,
sir, in this question, if the midterms will be same, then we just require one OR gate, right?
yeah. If S and C both are same, like this is also 1, 2, 4, 7, then we required only one gate, and this is I can write as either S or C. Okay.
Yes, sir. Yes, sir.
But if any changes, like for example, 5 is there in place of 4, then we have to create an individual gate. Okay, then we have to create a individual gate. We can't use the S because in the S 4 mean term 4 is available, but in the C no 4. So there is no option to separate a 4 and add a 5. So we required a individual OR gate. Okay. Now question number 8, I think so. We have to implement a 4 cross 1 using mux. Okay, sorry, for 4 cross 1 using NAND gate. Okay, so first of all, I write the equation. I naught is, sorry, Y is I naught S bar S naught bar plus I1 S1 bar S naught plus I2 S1 S naught bar plus I3 S1 S naught. Okay, we have to implement this. Now, if you see that I naught and S naught, we required two AND gate. Okay, sorry, basically we required it to complement output. So what I do, I just implement is S1 I take and S1 bar I take. Connect with one AND gate. So this one the S1 bar and here I am getting a S1. Similarly for the S naught, this is the S naught bar. Okay. Now with every S naught, S1, with I. If I take a ending of these three, so I am getting I naught, S1 bar, S. Okay. For the S1 bar, S naught we are taking from here, multiply with I1. So this is second end with I1, S1 bar, S naught. Sorry. S1 I am taking from here, S naught I am taking from here, I2, and with I1, I2, S1, S naught bar. Okay, last is the S1 I am taking here. Okay, and here we are using the OR gate. Okay, so my Y expression is created. Y is equal to I naught S1 bar S naught bar plus I1 S1 bar S naught plus I2 S1 S naught bar plus I3 S1 S naught. Any doubt in this?
No, sir.
Okay. Now, if you see the question, we have to implement only with the NAND gate. Okay, but here if you see, we implement with the NAND gate also with the OR gate and AND gate. Okay. Now, if you remember, when we are discussing the gates, logic gates, if A is connected here and B is connected here, what is the equation? A plus B. Okay. But in case of this one, if I use this one, now what is the equation? A bar plus B bar. Okay. And according to De Morgan's theorem, can I write it as a AB bar?
Yes, sir.
Okay. So if I apply a inverted input in OR gate, that become a NAND gate. Okay, that become a. So what should I do? I use one bubble here, one bubble here. Both bubble, that means 2-time inverting. Any change? No. One bubble here, one bubble here. Any change? No. One bubble here, one bubble here. Any change? No. One bubble here and one bubble here. Any change? No. That means no change in the final equation. Because both bubble effect will be cancel out to each other. That means y equation will be always same. Y equation will be changed. Internally what happened, that is different thing. But final output is same. There is no change in the output because cancel out the effect of each other. Okay. Now this will be NAND gate, NAND gate, NAND gate, NAND gate, and NAND gate. So how many NAND gate is required?
7.
1, 2, 3, 4, 5, 6, and 7. Question number 9. Node 5, NAND 15, and Node 20. Node gate have a 5 nanosecond, NAND is 15, and Node is 20 nanosecond. Okay, and so what is the output time taken? So like for example, this required a 15 nanosecond. This required a 20 nanosecond. Again, it is taking the 20 nanosecond, 5 nanosecond, 15 nanosecond, and 5 nanosecond. Clear? So we basically break this particular circuit into the multiple stages. Okay, one stage is this one. One stage is this one. And last stage is this one. Okay. Now, this is, I say, the stage 0, stage 1, stage 2, stage 3. Okay. For understanding of that one, I take one example. Basically, you have a 3 friend. Okay, three persons are there, A, B, C, and you are going to a trip. Okay, by your vehicle. One person A, that will be reach at a 7 p.m. one person B that will be reached at 6:55 p.m. and one person C that will be reached at 7:10 p.m. So when you start your trip, understand my question? What I am saying?
Sir, please repeat the question.
Three friends, those A, B, C, they are going to a trip together. Okay, going to a trip together. Now, one person A that will be reached at 7 p.m. at a meeting point. Person B will be reached at a 6:55, and person C will be reaching at 7:10 p.m. So when you start your trip,
At 7:10.
it's at 7:10. Okay, that means 7:10 when all three-person will be there. Now, similarly, concept we use here in this particularly this type of question. Stage 0, we apply all the input at the same time. That means there is no delay. At state 1 output, one output will be coming in 15 and one output will be coming in 20. Okay, so that means this will be the 15 nanosecond, this will be the 20 nanosecond. Okay, now this 15 go here directly. That means you have a 5 nanosecond delay. So 15 already 5. That means your total time delay is 20 nanosecond. Okay, no problem, because that is the independent path. But if you see for this particularly circuit, one input that is coming after 15 nanosecond delay, one input that is coming at 20 nanosecond delay. That means what is your time to reach a input?
20 nanosecond.
20 nanosecond. Why? Because 50, if you consider the 15 nanosecond, that means this output will not reach. So this is not a valid output. So you reach this particularly output will be reached at 20 nanosecond. That means you have to consider the other output or other input also a 20 nanosecond. Okay. Now 20 nanosecond and 20 nanosecond it will be provided. That means this output will be the 40 nanosecond. Okay. If we go here, 20 nanosecond delay, 5 will be the NOT gate. So this is a 25 nanosecond. Now again, this last third stage. Here one output will be received at 40 nanosecond, one input will be received at 25 nanosecond. So which we consider?
40.
40. Okay. Because till 40 both will be received, but till 25 only one will be received. So we consider when all input will be arrived. So 40 nanosecond we receive we consider the 40 nanosecond. Again, this gate will be providing a 50 nanosecond delay. So that means Y will be received at a 55 nanosecond. Understood?
Yes, sir.
Now in the question they are asking the X and Y both. So X will be after 20 nanosecond and Y will be after 55 nanosecond. Question number 10. I think you can solve it. Any doubt or should I repeat it? Yes, question number 10.
Sir, we can try by using this KMAP.
Okay.
One second, I can try.
So you can try. I just come within 2 minutes. Okay, 2 to 3 minutes. You just try this question. Hello. Yes. So solve it.
Yes, sir.
Any doubt?
No, sir.
Okay. So I directly switch to the question number 11. If anyone have any doubt, you can ask. Otherwise, we switch to the 11 question number 11. Question number 11 is so okay, we have this 4 cross 1 marks. We have to tell what is the value of x so that output y is equal to a plus b. Okay, find the value of x for this y is equal to a plus b. So if I write it down, so first of all, I write the equation. Okay, so equation is I naught is 0, so I am not writing the I naught. I am started with the I1. So a bar B. Okay, this is S1 bar, S naught, and this is I1 plus I2, S1 S naught bar, and I3 S1 S naught. So I2 is B bar, A B bar plus X bar A. Okay, now we have A bar B plus A B bar plus X bar A B. Okay. Any doubt? Now if we solve with the K map, so this is A, this is B, 0, 1, 0, 1. Okay, so it is y is equal to A plus B. That means we have a one term that is A. A means these two. Because when we create a group of these two, so we are only the constant is A. That is constant. A is what? So A. And if I am talking about the B, so we are getting this column where B is equal to 1. Clear? Any doubt? Yes or no?
No, sir.
Okay. Now if we go with the equation A bar B means this term. Okay. AB bar, that means this term. We required this term. Okay. And we are getting this term also. Only when this X bar is okay, that means X is 0. Okay, so one option is X is 0. Second option, if I put X bar as a 1, so this term is again a AB. Okay, we require three term A bar B, AB bar, and AB because this one is A bar B, this term is A B bar, this term is AB. So we already getting these two terms, we required only this term. How is it possible? Either the X bar is 1 or the X bar is A. In both scenario, X bar dot AB is AB. And if this term is AB, my Y is simplified is A plus B. So this term is equal to AB when X bar is 1 or X bar is 0. Or x bar is. This is also possible. If x bar is a, that means x is 0. If x bar is a, that means x is a bar. If x bar is b, so x is b bar. Now this and this option is available, so I take these two options. If this option is also possible available, so I can tick this option also, because this is also a correct option. But that is not available in option. Clear? Any doubt?
No, sir.
Okay. Now question number 12. Can you try it again? Question number 12. I just copy and paste it. Yes, anyone try it?
Sir, no doubt in the question number 12, but if you can discuss question number 13.
Yeah, I will discuss that one also. Yes, anyone no doubt in the question number 12?
No, sir. From my
Okay.
side, there is no doubt.
No, sir.
Any other?
13.
Okay. So we directly move to 13. I think we solved this type of question in the last class. I will solve it. So F A B C D is. Can anyone tell the terms? F A B C D is equal to phi F. If anyone open, can you tell me the terms?
Yes, it's 2, 3,
2, 3,
4, 6,
4, 6,
8, 10,
8, 10,
14, and 15.
14, and
Yes.
okay. So can I write it down as a sigma M 0, 1, 5, 7, 9, 11, 12, 13? Okay. Now they are asking if CD as a A and B as a select line and C is the and D is the available input. So they decided that which is the select line. So I just take AB as a select line. The 0, 0, 0, 1, 1, 0, and 1, 1. Okay, and CD as an input line. So I'm taking CD here. So it is 0, 0, 0, 1, 1, 0, and 1, 1. Remember that we can't write a gray code here because this is not a K-map. Okay. After that, can I write a particularly value binary code for every block? It is a 0, 0, 0, 0, 0, 1, 0, 0. Remember this thing because my in the question, the term of basically A, B, C, D will be in this form. So A is the MSB and D is the LSB. So first of all, I write the value of D, then C, then B, then A. Okay, 1, 0, 0, 0, and 1, 1. Similarly, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1. 1, 0, sorry, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, sorry, 0, 1, 1, 0, yeah. So 1, 0, 1, 0, 1, 1, 1. And last is 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, and 1, 1. Okay. Now I have to define the term. So 0 is present, 1 is present, 5 is present, 7 is present. Okay. Then 9, 11, 12, and 30. Okay. If I take this group, so this is for I0, I1, I2, and I3. Any doubt why it is I0, I1, I2, I3? Yes, anyone, any doubt why it is I0, I1,
No,
I2,
sir.
I3?
No, sir.
Sir, sir, like we can do it like in the earlier question that the way you did using the K map. Can you do this question in that method also?
K map, which method? This method.
No, sir. The question that we are doing now currently,
Hmm.
we can do it using the K map.
How we can do using the K map? Okay, we will solve that way also. Okay, if you are confusing, we will solve in that. Okay, so but this is the best way. Okay, I will solve how basically where you are getting confused in the K map. So okay, uh, fine. Now I naught is here. If you see for these two rows, C is the constant, D is variable. And what is the value of C? C is 0, so I just write a C bar. For this term and this term, D is constant and the value of D is 1. Similarly, for this one and this one, D is constant and the value of D is 1. And for this one, the value is C is constant and 0. So you have to connect I naught, I1, I2, I3. Here you connect a C bar, D, D, and C bar. Select line S1, S0 as the AB and Y. So that will be generate Y this way. Okay, so this is the best way to solve if we have a number of terms or basically the number of required input or select line is more than the multiplexer. Okay, we have a 4 input, but in the multiplexer we have only 2 select lines. Okay, so if this type of questions are given, the best way is this one. The second way, if you are talking, so the second way is that we have to take a K map and simplify the Boolean expression. Okay, so we have K map. The problem that you are facing, I will tell you in this. So we have a K map. A, B, C, D. Now the term is defined as a 0, 1, 5, 7, 9, sorry, 9, 11, 12, and 13. 12 and 13. Okay. Here, if you create a group here, this is your group. So what is your value? For this one is C bar D. Any doubt?
No, sir.
Now, if you are talking about the multiplexers, we have a 4 cross 1 marks where the select line is A and B with the S1 and S0, Y. Now, how we implement this stuff? If you write a equation for this K-man, what is the equation? R S1 bar S1 bar plus R1 S2 bar S1 plus I2 I2 S1 plus I3 S1. That means if you see the output equation, in every term, select line will be available. And what is the select line? A and B. Yes, what is the select line? A and B.
Yes, sir. A and B.
How will get this one? Because in this one, not no A available, no B available. This is the problem. Hello?
Yes, sir. Now got it. What's the issue with this using the KNAP?
Yes. So maybe possible we don't because if we create a group where the term A and B is not available, how we implement that term using the schema where the select line A and B is fixed. So that's why we better that we can apply the previous one. Any doubt? No?
No, sir.
So next question. The question number 14. I think that is question you can solve multiplexer question. Any doubt in question number 14, anyone? Should I solve it or any doubt in that one can tell me, please? I naught is what? 1. First of all, we write the equation. Y is I naught S1 bar S naught bar plus I1 S1 bar S naught plus I2 S1 S naught bar plus I3 S1 S naught. Now what is I naught? I naught is 1. What is I1? B plus C. What is I2? Again 1. And what is I3 is C bar. Now put the values and simply convert into the SOP form. Okay, sorry, canonical form, and just find out what is the mean terms and max terms are. Can you try it? Yes, you try it.
Sir, can you do this one?
Okay. So just put the values. So what is I naught is 1 A bar D bar plus I1 is B plus C A bar D plus I2 is again 1, so it is a D bar plus I3 is C bar, so it is a C bar D. Okay. Now we have a bar multiply with B plus B bar C plus C bar D bar plus A bar B multiply with C plus C bar D. Okay. Plus A D plus B bar C D. Okay. First term we are taking B, so this term. Second we are taking C, so this term. Now again AD bar, I convert it to the A D plus B bar C plus C bar D bar plus here only B is missing, so A B plus B bar C bar D. Break this one and find out what are the methods. Okay, just solve it. I give you 2 minutes. Yes, find it. Anyone? Should I move forward? Yes, students, should I move forward? Okay. Question number 15 is somehow similar to this one. Now again the y is a bar b bar times c, because now I notice c. I notice c, I1 is b plus c, I2 is c bar, and I3 is c. So I0 S1 bar, S0 bar plus I1 S1 bar plus I2 a b bar plus I3, so d a c bar b bar plus d plus a bar c, a bar c. Okay, now find out the mean terms. Convert into the standard canonical form, then mean. Any doubt? Can you hear me? Yes. After that, if you have any doubt, you can ask.
Sir,
Yeah.
sir, in GA5, there are also some doubts.
Mm-hmm. Then just tell me which question.
9, 10, and 11.
Um, so question number 9. Question number 9. The term is F is P C bar D bar plus A B C plus B C D bar plus A bar B C plus A D bar C D plus A C D bar. Okay. Now I have to go again. I am not converting directly into the canonical form. I am directly writing the terms in KML. But if you have any doubt, you can first of all convert into the canonical form, then write the terms in KML. So A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1. One more thing we have to check, what is the okay, F. Now C bar D bar, C bar D bar, that means this complete column. Okay. Now in this one, C bar D bar, B is 1. So where B is 1 in this position and this position, so both will be 1. Okay, in this way I can write AB. AB, that means this particularly row. Now in this AB, C is also 1. So C is 1 in these two positions, so that means C is. Okay. C D bar. So C D bar is this column. Here B is 1. So B is 1 in these two rows. This column and these two rows is this one and this one. A bar B. So this row. C is 1. C is 1 in these two. So that means this one. Okay. CD. CD is this one. Now A B bar. So this and C D bar. This column A is 1. So A is 1 in this two position. Already it is available. Sorry, this one. Okay. Now if I create a group, so 3 groups possible. 1, 2, and 3. This is 1, this is group 2, and last one is group. So that is for group 1, it is B is constant and C is constant. For the group 2, AC. And for the group 3, B, BC, AC, and BD bar. Okay. Now, if you see that it is a POS form also mentioned. So where one is not available, that all also. Okay. For the POS, again 3 groups. One is the top row, second is the second column, and third one is this. And okay, for the top row, both A and B are 0, 0. A plus B. For the second column, C is 0 and D is 1. Okay, and this top and bottom group of 4, B is 0 and C is 0. Any doubt? Clear?
Yes, sir. Clearly.
Okay. Now question number 10. We have to implement, I think, same expression. Check. B, C bar, D bar, okay. A, B, C, B, C, D bar, A bar, B, C, A, B, C, D bar, and B, C, D. So this is the term. Now I have to implement with the NAND gate. So what should I do? I just first implement BC, then AC, and then D. With the D, I use a one NAND gate, so I convert it to the D bar. Okay, and now I use 1, 2, 3, and using the 4. Okay. If I use one bubble here and one bubble here, no change in the output. One bubble and one bubble, no change in the output. One bubble and one bubble, no change in the output. Okay. So for implementing of this one, we required a 4 2-input NAND gate. 1, 2, 3, and 4, and 1 input. This is question number 10, and this is question number. Okay.
Yes, sir.
Any other doubt?
So the last two questions, 16 and 17.
I think question number 16, the answer is wrong. Okay, so in the question number 16, it is mentioned that two inputs are available, two inputs are available, A and B. Okay, and the output is Y. It is high when A greater than B. Okay, so if two inputs are available, A and B, okay, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, and okay, I just write A single time and B. Okay, again A 0, 1, B is 0, 0, 0, 1, 1, 0, and 1, 1. A is 1, 0, B is 0, 0, 0, 1, 1, 1, 1, sorry, 1, 0, and 1, 1. And last is A is 1, 1, 0, 0, 0, 1, 1, 0, and 1. Okay, clear? So total 16 combination are created because every input is 2 bit. So total number of bits is 4, and if 4 bits, so total 16 combination is possible. Now when the output Y is 1, if A should be greater than or equal to B. So here you can see A is 0, 0, B 0, 0, that means here it is 1. And rest 3 are 0. 0, 1, it is 0, 0, so it is greater, so 1, and it is equal, so 1. Remaining 2 are 0. It is 1, 0, 0, 0, 1, 0, 1, greater, 1, 0 equal, and 1, 1 less, so 0. And when our input is 1, 1, all will be 1. Because 3 condition is 0, less than, and 1 is the last one is the equal. Okay. Now we have to put it into the K-map. A1, A0, B1, B0. So 0, 4, 5, 8, 9, 10, 12, 13, 14, 15. Okay, so this is the so total 5 terms are available. One is this one. One group is this. Another group, second, these two and these two. Group third, these four. Group four, and these four group. So total 5 terms are available, and every terms have a 2 variables. Okay, but in the option only 4 terms are available. Okay, so the answer is this one is wrong. Clear? Any doubt?
Yes, sir, it's clear now.
Now the minimum 2 input gate required to implement the Boolean expression if no complement inputs are available. Question number 17. A, B, C, D. The term is 1, 1, 4, 5, 8, 9, 11. Okay. D is 0, 2, 10, 12 and 14. Okay. So we create a group. Two groups are possible. One with this one. Second. So the answer is C bar for this group. And last is C bar B B bar with A and finally okay. Now it is mentioned in the question that two input gate. So this is basically NOT and NOT gate. I can implement with the NAND gate also. So two input gate. C. This is the NAND gate. B. NAND gate with A. And then okay. The number of gate is 4. If you have to implement with only NAND gate, so what you have to do? Use one NAND gate more here, okay, and one complement. So this NAND gate and this complement will be cancel out to each other because you are taking two time inverter. Okay, and two time inverter will be cancel out the effect. Now this two time inverter, so that means there is no use of this one. I can directly connect C here. I connect one bubble here and one bubble here. Both will be cancel out the effect. Now this is the NAND gate 1, NAND gate 2, and NAND gate 3. So if you have to implement with the NAND gate, 3 NAND gate is required.
Sir, but for the C bar, we'll use two more NAND gates, right? So
No,
it
so
will
2
be,
will be cancelled out now.
yes, sir.
Effect of 2 NAND gate will be cancelled out because it is a NOT and NOT. If you connect 2 NOT in the cascade form, so you are getting the same output. So why we use the 2 NAND gate?
Yes, sir, got it.
Okay. Any other doubt? Now from Monday, we start with the week 7. Clear?
Yes, sir.
So I think Monday you just come with the watching videos of week 7. So we will discuss the problems, what you are facing. If any doubt in the topic, we will discuss that. Then after we start the questions. So thank you all.
Thank you, sir.